So let us discuss this example of norm. Okay, so already in last video we have seen example of the same type. Okay, here also we have the same type of example, just inequality is different. Okay, so see what we have subset Rn. Okay, we have a set Rn, n dimension, and they have defined three norms: norm 1, norm 2 and norm infinity, having three different definitions. Okay, so they have already told us these are norm. Okay, and in our previous videos we have already proved these are norm on Rn. Okay, but they have mentioned these are norm on Rn, and simply we have to prove this inequality. Okay, so what will I do? First of all, we will focus on this part of inequality. We will try to prove it, and after that we will cover this inequality, and at the end we will join them, so we'll get a required result. Okay, so let us do that. Yeah, here clearly. Okay, clearly, what can I write clearly? Mod xi is always less than or equal to maximum of mod xi I running from 1 to n. So that means if you consider all x1, x2 and so on xn, and if you take their maximum, obviously each of them is less than or equal to maximum of it. For example, suppose we consider few numbers here, 2, 7, 5, 3. Okay, what is the maximum here? Obviously 7. So that's why each element, 2 less than or equal to 7, 7 less than or equal to, equality is there, and so that's why we can write 5 less than or equal to 7, 3 less than or equal to 7. That means each element of a set is less than or equal to maximum of that set. So same thing I wrote here. Okay, so after that what will I do? Yeah, this one we can replace by norm infinity. So therefore mod xi is less than or equal to norm x infinity, since it is definition of norm infinity. After that, what will I do? Actually, this is true for all I running from 1 to n. After that, what will I do? I will take square of both sides. So what will happen if I take square of both sides? So if you take square, no need to take mod, since the square cannot be negative. Getting? So this is less than or equal to norm x infinity square, and this is true for all I running from 1 to n. So therefore x1 square is less than or equal to this one. Getting? X2 square is less than or equal to this one, as well as xn square is also less than or equal to this one. So if you add all these elements, what will happen? X1 square plus x2 square plus and so on xn square less than or equal to, see, the first one is less than norm x infinity square, second one is also less than norm x infinity square, third one is also, each of them, okay, each of them is less than norm x infinity square. Okay, so see, will you tell me this is nothing but, see, summation xi square, here also summation xi square, simply there is root and here is no any root. That means this is nothing but I can write, so therefore norm x2 square I can write. Okay, so if you take square of it, you will have the same thing, right? And this is less than or equal to, in the right hand side what will happen, we are having a same term, but it is repeated how many number of times? N number of times. So therefore this is n norm x infinity square. After that I will take square root of both sides. Okay, obviously positive square root. So therefore norm x2 less than or equal to root n norm x infinity. By taking square root cancel, here square root cancel, simply we will have square root there. Okay, see, but the required inequality is slightly different. So what will I do? I will multiply both sides by root n. Okay, so let us multiply. So multiplying both sides by root n. See what will happen if I multiply both sides by root n. Here if you multiply, we'll have root n x2 less than or equal to, if you multiply this, already root n is there and again we are multiplying by root n, so root n into root n simply we will have, so n norm x infinity, and this is true for all x belongs to Rn. So in this way we got the first inequality. Okay, I will call it as equation number 1. So this part is we have done. Okay, so see, let us focus on this part now. Okay, now we are trying to prove this inequality, and at the end we are going to combine. Okay, so make a screenshot of it, and after that we'll go for the remaining half of this problem. Okay, so let us continue. So now we are going to prove the remaining half of this inequality. Okay, so norm x1 is there, so obviously I will start with norm x1. So see, for x belongs to Rn, consider, see, I'm going to consider norm x1. So tell me, what is its definition? A definition is already given here. Okay, so this is its definition. So that means mod x1 plus mod x2 plus and so on. What will I have? Mod xn. So now what will I do? I will take square of both sides. See what will happen if I take square of both sides. So therefore norm x1 square, here also we have to take square, mod x1 plus mod x2 plus and so on mod xn square. Okay, so see, bracket square formula we have to use. Okay, so because of that formula we will have x1 square plus x2 square plus and so on xn square, that means square of each term first, plus summation to mod xi xj, this term will be there, and where I should be, I and j should vary from 1 to n. Okay, so this type of thing we will have, right? See, maybe you will think that how did it come? Okay, so actually the reason is a plus b bracket square formula. Okay, so when you have a plus b bracket square formula, what we do, first we write square of a, after that we write square of b, plus we write 2ab, right? So same thing is here, that means first we write square of all and after write 2 into ab, that time of formula we have. Suppose you have a plus b plus c square, so that time what will happen, a square plus b square plus c square plus 2ab plus 2bc plus 2c. Okay, that type of thing we have here. Okay, so because of that, this multiple of 2ab 2bc, that part is covered by this term. Okay, summation is there, and a square b square individual squares, we have written those things here. So this is equal to, this is equal to, this is nothing but see, this is nothing but, you can easily see, so a summation x1 square x2 square x3 square, same thing we have, simply we don't have a square root here. So that's why this is definition of norm x2, but square root is not there, so that's why I supposed to write norm x2 square. Getting now, since square root is not there, that means square is there, right? So this is equal plus summation, I will write the same, 1 less than or equal to I less than j less than or equal to n to mod xi mod xj. Okay, actually it is less than or equal to, it is less than or equal to norm x2 square plus summation 1 less than or equal to I less than j less than or equal to n. We can write this is xi square plus xj square. Okay, so maybe you will think how did it come? So actually the reason I will write here, just a minute. See, as you know, square of any number cannot be negative. So because of that, if you write a minus b square, obviously it is greater than or equal to 0, since square cannot be negative. So if you expand the bracket, what will you have? A square minus 2ab plus b square greater than or equal to 0. So what will I do? See, this middle term minus 2ab, I will shift to the right hand side. So therefore we will have a square plus b square greater than or equal to 2ab. So this is a reason. How could I write it? This is a reason. Okay, so see, 2ab, that type of term we have, so obviously it is less than or equal to a square plus b square. Is it clear to you? 2ab. Okay, this term 2ab, 2, suppose consider this is a, this is b, so this is less than or equal to a square plus b square. So this logic we applied here. Okay, just a minute. So let us continue. Okay, I removed this part. So see, I will require some more space. So this is equal to norm x2 square, and if you expand the summation, see what will happen, you can take I1. Okay, you can start from 1, so x1 square plus j should be strictly greater than I, that means j can be 2, can be 3, can be 4, but it cannot 1. So that's why x2 square plus, again, okay, for I1 j1, for I1 j2 j3, sorry, I can write x1 square plus x3 square, next x1 square plus x4 square. Okay, plus and so on, we can reach up to x1 square plus xn square. That means what we have done, we have fixed the first term and simply we varied second term. So now after reaching to n, what will I do? My I will be 2 now, okay, 2. That means we will have plus x2 square. So if your I is 2, j should be strictly greater than I. So j can be 3, 4 like that. So x3 square. Next x2 square plus x4 square. Next x2 square plus x5 square. Okay, in this way you can vary I, you can vary j, okay, and at the end you can reach to n. So that's why x n minus 1 square plus xn square. So see, this is equal to norm x2 square. Okay, so if you see the properly all these numbers, you can easily understand that each term, okay, each term is appearing n minus 1 number of times. Okay, if you consider x1 square, it is repeating n minus 1 number of times, x2 square, it is repeating n minus 1 number of times. So simply I can write this is simply n minus 1 summation xi square, I running from 1 to n. Okay, so see, this is equal to norm x2 square plus n minus 1, and yeah, this is nothing but same again, getting simply we don't have a square root. So what we do when we don't have a square root, we write square. So this is norm x2 square. So this is equal to, see, both of them have a same term, norm x2 square and norm x2 square. So we can take it common. So if you can take a norm x2 square common, so here we will have 1 and here we will have n minus 1. So 1 and minus 1 will get cancelled to each other and we will have, so therefore, so left hand side we cannot forget, this is our left hand side, norm x1 square less than or equal to, somewhere we have got here, we have got less than or equal to n norm x2 square. So now what will I do? I will take square root. Okay, I will take square root of both sides, but we don't have a much space, so make a screenshot of it and after that we will go further, please. Okay, so let us continue. See, here we have taken square root of both sides, so square will get cancelled and we will have root n. Okay, that term we will have, this is 2. So see, same thing we have got, norm x1 less than or equal to root n norm x2. So we will simply combine 1 and 2. So from 1 and 2, norm x1 less than or equal to root n norm x2, and the second inequality we had got in 1. Okay, n norm x infinity, and this is true for each x belongs to Rn. Okay, so therefore we proved, in this way we proved required inequality. Thank you. Make a screenshot of it and after that we will stop. Thank you. Bye.